Hello, my name is Danny Nowlan and I'm the Director of ChassisSim Technologies. In this episode of Dan's Vehicle Dynamics Corner, we're going to be discussing race car simulation, what you need to do to get started. Ladies and gentlemen, the point of today's tutorial is not to give you a 500-point breakdown list of everything you need to do to get your race car simulation from your race car model from a blank sheet of paper to a full fire breathing vehicle model that you can use in practice. Rather, today what we're going to be talking about is to really demystify what you need to do to get all the necessary information you need. So you've got all the data to hand to get going with your vehicle dynamic model. That's our goal today, because one of the greatest myths that you see with race car simulation and people starting with vehicle models is that they get so obsessed on getting all the fine details of the race car sorted out that they never really get started in the first place. And I can tell you, after having done this for over 15 years, the best way to get going is you start off simple and then you get complicated. Do not do it the other way around, because if you do it the other way around, you'll never get started. So what we're going to be doing is walking you through a simple 7-step process of the information that you need to get going. So without further ado, let's get started. First things first, what we need is a measurement pad, so we can measure all the relevant details we need for the race car. Now, what we need to do is we put the car on a flat patch, and if it's an open wheeler, if we can, we take off the floor so we can get to we can get to all the pickup points. Now, in terms of your flat patch, in an ideal world, obviously you would want it as flat as perfectly possible. But in reality, you can get away with tolerances of about, plus or minus 1 or 2 mil. Is it ideal? No. But the important thing is that you get started, because one of the big myths I see in this business is that you see a lot of people thinking, oh my Lord, we've got to have an absolutely nanometric perfect measurement pad. Well, I can tell you right now, ladies and gentlemen, I've had to measure up race cars in as pit conditions. Both myself and and some of my colleagues have been placed in this situation, and I can tell you right now that all you need to do is basically have good attention to detail, know what you're measuring, and also have a very good awareness of the numbers. So that's our first primer, making sure that we've got the measurement pad so we can get our suspension geometry pickup points appropriately measured, and we can get things like our tracks and our wheelbases measured. Now, the second primer we need, particularly with regards to measuring suspension geometry, is this little sheet that I've outlined before. This little sheet is actually battle proven. I actually use this to measure up an open wheeler race car after coming off a long haul, after coming off a 14-hour long haul, after coming after a long haul flight. Now, the beauty about this little, the beauty about this little critter here, you can see that at a at a at an appropriate fingers point, you've got everything that you're going to need at your at your fingertips. Have a look at this. You'll see here that for my upper and lower pickup points, I'm actually measuring across the pickup points. Now, I'm doing that for a reason. The reason I'm doing that is it basically minimizes error. But the great thing about it is that once you've got all those points to hand, putting them into your suspension geometry package then becomes absolute child's play. And indeed, what I'll often do is I will fill in this little template here, which is what I've done for a particular race car. And as you can see, I've got my upper pickup points and I've got my lower pickup points, as you can see, for a double wishbone arrangement. And you can see that I've got, as you can see in the lower picture, I've got the pickup points for the lower points illustrated. And that basically gives me everything I need. And what I'll have at the same time is I'll have my suspension geometry package of choice open, whether it be Mitchell, SUSPROG, or the ChassisSim suspension geometry calculator, and I'll just be basically plugging it all in, hitting the analyze configuration, and making sure I don't come up with any silly numbers. So consequently, if you do that, that's a really good way just to sanity check that you do that you're doing everything. Primer free, measuring the center of gravity height. Now, there are a number of ways that you can do this, but the most effective way that I found is actually tilting the car on the side. Now, as you can now, believe it or not, I've actually seen videos of this being done for a 1500 kilo stock car. And I can tell you right now, it actually has worked really, really, really well. And the center of gravity can basically be calculated by the CG height is basically 0.5 times the mean track plus the track offset times tan 90 minus whatever the banking angle is. TM is the mean track of the vehicle. T offset is whatever you've got the tires held in. Now, I would probably recommend just on that that you basically have a good piece of angle iron and you basically pump up the tires to probably maybe about 4 or 5 psi over their hot running tire pressure. What you want to do, the reason you want to do that is basically just to keep the platform stable so you can get a good measure. And once you've got the CG height, you can then basically let the tire pressures down to hot tire pressure, and then you just simply offset your CG height from there. Your primer 4, baseline tire modeling with tire data. Now, this is something I get asked about an awful lot about. Okay, we've got some tire test rig data. How do we incorporate it into our tire vehicle modeling, and what bit of the data do we look like? Okay, the bits of the data that you're looking for is basically what you want is the plot of max lateral force versus load your plot of max lateral force versus load. Now, in a lot of tire data, you'll actually be getting plots of slip angle versus tire force for various loads. What you want to be doing is looking at where those peak values are for those curves, and that gives you your baseline tire curve. Now, let me state very, very, very directly here, it's a start point. It is not the end. This is not the be all and end. This is not the be all and end all. And in further tutorials, we're going to be talking about at length some useful tips and tricks that you can use to refine that data a little bit more. But the whole point of this is to get something to get you going and up and breathing. That really is our goal here. Primer 5, tying up our loose lands. Deducing the engine curve. Okay, put the car on a rolling road dyno. There's now enough aftermarket automotive tuning shops that you can book some time, put it on a rolling road dyno, and get the exact engine curve that you want. Now, if you don't have access to a rolling road dyno, what you do is you basically take the peak power and torque values and fill in the gaps. Here's a hint. If you need any further help, go and chase down a good engine tuner and be nice to them. In my experience, engine tuners are very, very susceptible to flattery and alcohol. So if you do that, you should be able to fill in your appropriate, you should be able to get a good approximation of the engine curve. Now, in terms of starting off with the aero map, this is something I've spoken about in a number of different articles on the ChassisSim blog and also on Racecar Engineering. But to get going, what I would recommend is that you do a hand calc of downforce and drag and aero balance at the end of the main straight. That's always proven to be a really good yardstick to get a vehicle model up and running. And lastly, for deducing the motion ratios, you just simply plot a plot of damper versus wheel movement. That's all you need to do. That's if you can do that, you're laughing. The last step in getting going with race car simulation is basically what we at ChassisSim refer to as the monster file. And what the monster file is it basically we take a single flying lap of data, we export it at 50 hertz, And from this, we can basically use this to construct the circuit properties and start doing our modeling, such as things like using the aero estimation, aero tire modeling, the tire estimation, and the tire force modeling. Now, effectively, what your monster file is it basically plots track distance in meters, RPM, lateral G, longitudinal G, all your four damper displacements in millimeters. Now, I should add that your damper displacements, this may vary from racecar simulation to racecar simulation package. For ChassisSim, positive is with the dampers in bump. The next column beyond the dampers you can see there is your steered angle in degrees at the tire, not the steering wheel. The second last column is throttle, and the last column is speed in kilometers per hour. So as you can see, putting together the necessary steps that you need to get going with a race car, to construct a race car vehicle model, it isn't rocket science. It's just attention to detail, using a bit of common sense, and knowing what to look for. Because let's face it, the important thing to do is to get going. There's an old saying: to win a race, you first got to turn up, and this is an exact example of turning up. Now, obviously, there's obviously a bit more detail to this, but you can find more articles than this in my articles in race car engineering, but also on the ChassisSim blog. I should also say though that that in November 2011, we're going to be talking about this at more detail at Professional Motorsport World, because ChassisSim is presenting a workshop there, race car simulation, practical approaches that deliver results. We're also presenting the similar presentation at the PRI trade show on the Thursday and the Friday of the PRI trade show. So I look forward to seeing you all there.